Hello, am I audible? Can you all hear me?
Yes, sir.
Okay, all of us are here, or someone else has to join more?
Yes, sir.
Everyone is here, or some more are coming? Just let me know. Shall we start?
Yes, sir.
Okay, nobody else is going to join now?
No, sir.
Okay, can we have our videos on? If it is possible, can we have our videos on? Is the host here? Not able to share my screen now. Okay, no problem. Whoever has problem in switching on the camera, no problem. It was just for rectification that you're concentrating here or not. Actually, I don't know who the host is here. Yes, the sharing button is off for me. Give me a minute. Actually, I'm not able to share my screen. The host is not letting me to. I'll have to check whether who is the host. Just give me 2 more minutes. I'll have to check with the administration here. Okay, I guess I'll have to work with it only. This whiteboard provided by the Zoom app. Yeah. So we had to discuss about the measurement of units and the dimensions, right? Everybody, please at least switch on your mic so that you can correspond me. Right? Okay. So we'll be discussing it. We'll be just having a revision of it. Okay, so that you get like a brief intercept about this chapter. So starting with it, we had physical quantities. How many physical quantities? Physical quantities are divided into 2 quantities. If I write physical quantity was divided into 2 parts. Okay, one was fundamental units, fundamental quantities, and another derived quantities. Agree, everyone?
Yes, sir.
Okay, good. How many fundamental quantities were there? How many fundamental quantities were there?
7, sir.
7. Mass, time, length,
Temperature.
is there anyone from learning room? Yeah, now I am the host. Okay, thank you. Earlier I was not able to see it. No problem, no problem. Actually, I was not able to share the screen. Okay, thank you.
Yeah. Okay.
Now I can share my screen. Can you all see my screen now?
Yes, sir.
Okay, that's good. That's good. Okay. So as we were going on, how many fundamental quantities are there?
7.
7 fundamental quantities. Very good. Right? What are they? Fundamental quantities. Mass.
Length.
Time.
Temperature.
Very good. Length. Temperature. Quantity of matter. And luminous intensity. Right? Okay. Till here, everyone agree with me?
Yes, sir.
Yes,
Basically, these were the basics. Mass at the unit of kg, time at the unit of meter, length, time at the unit of seconds, length at the unit of meter, temperature Kelvin. Quantity of matter, anybody?
moles.
Moles, very good. And luminous intensity?
Candela.
Candela, you all know this. You're in class 11th or 12th?
11th.
11th, okay. So you have completed this chapter now?
No, sir.
Okay, I need to teach you this chapter, or you just a revision kind of thing you require. Have you studied this chapter, or somebody has taught you this earlier or not?
Sir, we all joined late, so we are not.
I'm not getting it. Like, have anyone taught you this earlier or not?
Yes, sir.
Huh?
Yes, sir.
Yes, sir. That's good. Okay, so you all have these notes.
No,
Yes,
no,
sir.
sir. We all joined late, so I'm not having the notes.
You're not having the notes. Okay, for this particular class only, na? The first class, na? Okay, I'll teach you everything then. Okay, leave that. I'll teach you everything. No problem. Who was not
Okay.
having the notes? Okay, so see, basically, this chapter starts with the units. Okay, we will discuss about the different kinds of quantities and the units that we'll be discussing in the 11th and 12th course. So this chapter forms the base of class 11th and 12th physics. You all have to listen here carefully and concentrate here, because yet this chapter contains very easy concepts, but these are most important. Okay, so basically what happens, there is something called physical quantities. Physical quantities. What are physical quantities? Okay, so physical quantities are those quantities which can be measured directly or indirectly. Quantities which can be measured directly or indirectly. I want participation from all of you, please, because only then you'll be understanding this chapter. Okay, physical quantities are those quantities which can be measured directly or indirectly. Okay, and physical quantities are like of two kinds basically. One is fundamental quantities. Fundamental quantities. Another one is derived quantities. Derived quantities.
Sorry to interrupt you, Adarsh. Vidisha this side.
Oh yes,
Yeah.
ma'am.
So students, just switch on your camera. If your camera is not on, Adarsh, you can remove them from the class. It's not required they have to attend the class if their camera is not on. Okay.
Okay, ma'am.
You have all rights to remove them from the class. It's not required if the camera is not on. Okay.
Okay, ma'am.
I hope I'm clear with all the students, Rohit and Vandana and Akhil. Yeah, Akhil, are you there? Vandana, Nivedita, you are not visible.
Ma'am, Vandana said that she has some problem with the camera. Like,
Sir,
Okay.
I've joined through my laptop.
Yes.
okay,
Akhil,
okay. Then.
Akhil,
Yes, ma'am.
switch on your camera. If your camera is not on, sir will remove you from the class. Nivedita, she is not visible actually. Nivedita, are you there? Yes. Okay. Adarsh, you can take up the class. Yeah. So if anyone's camera is off or something without any information to you or any information which you feel it's not genuine, you can remove off them from the class, whether it is physics class of today and tomorrow or math class. Okay. It's,
Okay,
yeah.
ma'am.
Thank you.
Thank you, ma'am. Okay. So one is fundamental quantities and another one is derived quantities. Fundamental quantities are self-made quantities. Okay, they do not require any help to get themselves defined. Okay, you do not require anything to define mass or time or length or temperature. But if I ask you, how do you define velocity? Anybody define velocity? You must have learned velocity in class 9th. How do you define velocity? Go on. Okay, no problem.
Rate of change
So,
of speed.
pardon, Vandana?
Rate of change of speed.
Rate of change of speed. No, that is not velocity. That is acceleration. Velocity is distance covered by time taken. Let me write it. Distance by time. Distance covered or displacement. Basically, I should write. Basically, velocity is related with displacement. If I need to be exact, I should write displacement by time. Let's study this in the next chapter. So displacement by time. What kind of quantity displacement is? Among these, Can you classify? What kind of quantity displacement is? Isn't it the length? Agree with me, everyone? It is a kind of length. Now, displacement is a kind of length only. And time, you all know it is time. So what the thing is, velocity is a quantity that that requires the definition of length and time to get it defined. Agree with me, yes or no?
Yes, sir.
Okay, very good. So this is a derived quantity. Okay, derived quantities require the help of fundamental quantities to get themselves defined. That is the definition. Understood, everyone, or not? Okay, shall we move further? Do you need the definitions? Do you need the definitions? Who didn't have the note? Anybody, I guess, did not have that notes there. Okay, so I'm not giving the definitions. If you require, just let me know. This definition I missed, I'll give it again. Okay, good. Now, next thing that this chapter has is the units. Okay, we have to see the conversion of units. Next topic that we have to consider is conversion of units. So in conversion of units, any unit, any quantity, we express in two terms. We write N and U. What is N and what is U? What is N and what is U? N is a numerical value. Numerical value. And U is the unit. For example, if I give you any length and ask like you measure it and tell me the value, what will you say? You say, sir, this is 5 centimeter, or this is 10 centimeter, or this is 2 meters. You say something like this now. So how do you write? You write a numerical value and the respective unit. This is how you write any quantities, explain any quantities. Agree? Everyone agree with me?
Yes, sir.
Okay. So N and U is constant for any terms. For example, if I write, you must be knowing there are different system of units, CGS unit, centigrams and second unit. There is SI unit. There is foot pound second unit. There is English metric system of units. There are different system of units. Okay. So we have the same measurement and different values we write. Agree or not? So if I write in SI unit, what is 5? If I am measuring the length, okay. So SI unit, I'll be writing 5 meters. So how much centimeters will I be writing then?
500.
500 centimeters. Good. Is the value changing? Is the value changing? Yes or no? I can see Nivedita nodding yes. Akhil also yes. Ritika? She is also yes. Rohit? No, the value is not changing. You measure 5 meter or you measure 500 centimeter, you'll give me the same length, isn't it? If I ask you to cut a piece of cloth of 5 meters, like if somebody uses this measurement and other one uses this measurement, I'll get different length of cloth. No, nah. Both will give me the same value of cloth. So the values are not changing. So for any quantity, then this N and U is constant. This N and U is constant. Okay, you write 5 centimeter. You write 5 meter. You write 500 centimeter. You write 5,000 millimeter. All of them are same. Even this will be same. 5,000 millimeter. That's why you are putting equal to sign. How can you say this is changing? Are you getting my point? Everyone?
Yes, sir.
You cannot. I can see that is enough. Okay, good. So if I'm changing this, I have in some other system of units, I'm having N1 numerical value and U1 unit. And in some other another system of units, I'm having N2 numerical value and U2 unit. So both will be showing me the same result. Otherwise, that is wrong. Otherwise, that should be wrong. If 5 meter, I need the same measurement in some other units and they are showing 50 centimeter. So this is wrong. It should be 500 centimeter. Because you have specified the rule that 1 meter should be 100 centimeters. So in any system of unit I go, any system of unit. Okay. So the N1 U1 ratio should be multiplication. This product should be constant. Agree or not? Okay. We have this numerical based on this particular thing. That will be we'll be studying after dimensions. When you'll be studying dimensions, after that we have to do this. Okay. Now, okay. Next is, what is the desirable characteristics of physical quantities? Can anybody say tell me what are the characteristics of physical quantities? Characteristics of physical quantities. Anybody? Even if any one you didn't know, or you can see your notes if it is near you. Okay, let me proceed. It should be well defined. It should be well defined. First thing, a physical quantity should be well defined. Okay, it should not vary in different aspects. Okay, another thing, it should be of convenient size. It should be of convenient size. It should be of convenient size. Third point, it should not change with time. It should not change with time. It should not change with time. It should be easily reproducible. It should be easily reproducible. Okay. Last thing, it should be indestructible. It should be indestructible. Okay, are you understanding these points? Any quantity, if I'm writing, that should be well defined, that should not change with time. Like if you have taken 5 meters, so 5 meters should not vary with different times, isn't it? That should be constant. Okay, 5 meters for any time, it should be constant. Next thing, it should be easily reproducible. If you have lost one scale, you should get the another one with the same length. Okay, next thing, it should be indestructible. It should not be like if you have set any unit for particular thing and now we cannot see it. It has like it vanished. Okay, then how will you take the other readings after this time? So all these things should be there for any physical quantity. Agree, everyone? I guess you all are taking the notes, so I'll be now providing the notes to you properly. Okay, I'll be providing you the notes. I'll write everything. Do you require that? You require the notes? Okay, then I'll be writing everything. And I'll give you time also. No problem. Okay, good. So you understand these points? They may ask you in the exam, school exam.
Sir, am I audible?
Yeah, you are.
Sir, in the fourth point, it says it should be easily reproducible. Actually, what does it mean?
See, basically what happens, like you have to get it everywhere. Okay, this should be accessible to everyone. If you have lost one of those units, this another one should be reproducing it. Okay, we should get the next one. It should not be like if I lost one of those scaling units and now I'm not getting anything like that. Are you getting my point? You can see that 1 kg weigh with every vegetable wala, isn't it? It should be with everyone. Correct? If he loses one, he should get another one easily. Now see, if what happened if those 1 kg weigh or 2 kg weighs that every vegetable sellers are using was not easily accessible, will that weigh will be with everyone or not? Then everyone will not be containing that. Then they'll be using some different quantities or different measurement units, and again that will be creating a disuniformity. Are you getting my point? So that should be
Yes,
easily
sir.
accessible or reproducible. Got it? Good. Okay. Next thing, we'll be describing what are the fundamental and derived quantities. Written, everyone? Shall you move to the next page? Okay. Fundamental and derived quantities. So basically, we have to define some fundamental quantities. How we take those fundamental quantities? Okay. How we got those fundamental quantities basically? Like for example, if I say that this is 1 kg, so how do I say that this is 1 kg? Somebody must have found it or discovered it, isn't it? So we'll be describing that. First of all, fundamental units. Let us have that definition. Fundamental units. What is a fundamental unit? The units which can neither be derived from other units nor they can be resolved further into more simpler units. I hope you must be understanding this definition. Fundamental units can neither be derived from any other quantities. You cannot derive these quantities. These are already placed there. Another thing, we cannot resolve into the further simpler quantities. For example, we resolved velocity into length upon time, right? But we cannot resolve these fundamental quantities into other quantities. Agree, everyone? Good. Example, you write mass, length, time, etc. Then we have derived quantities. Or first we shall do this fundamental only, then we'll get into derived quantities. Or we shall write it there. It should be at one place only. Derived quantities. Okay, so what are derived quantities? All physical quantities which can be expressed in terms of fundamental quantities. Fundamental quantities are called derived quantities. The right one, please. Example: velocity, acceleration, force, etc. Write this down. Written, everyone? Okay, good. Any doubt in any of the words of the definition? Or is the color suitable for you? Any problem there? Okay. Okay. Written, shall we move on? Right. Good. So now we'll be seeing the different system of units. Next topic, that will be system of units. System of units. So what are the different system of units? First one will be SI unit, or let us start from the basics. Let us take CGS unit. CGS unit. Second, we have FPS unit. Okay, third, we have MKS unit. There are more. Let us first define it. This is centigram second. Centigram second. This is foot pound second. Okay. This is meter kilogram second. Okay. Write this, then we'll be moving on to the next page, or I can write it here. Okay. Then we have SI unit. SI unit. That is International System of Unit. International System of Unit. Basically, this was a French name, and that was called Systeme Internationale. Okay, this was the meaning, International System of Units, and SI word came from Systeme Internationale. That was a French word. Basically, what happened now? This FPS was basically used in British culture, and CGS was used in France, basically. Yeah, France. CGS, they were using France, and then MKS in a different country. So what happened? Scientists sat at one place and they decided that this is something complicated. Like you are using some different unit, you are using some different. This is now even complicated. Now, when you go to a different country and you see that you have to use dollar, or you have to see, you have to use pounds, or you have to use euro or yen, or different currencies are there. So that makes quite difficulty there now, isn't it? So what they did, they sat at UN and they decided there will be an international stock, and according to that, all the exchanges will be done. So with that, we agree that $1 is 80 of Indian rupees. You must be knowing that, right? So same way, much earlier in 1960. Okay, so there was a general conference of weights and measures, and the scientists sat there and decided we should have one international system of units and we should follow them. Got it? So that there is uniformity in every quantity we get. For example, like we were getting some of the quantities in gram in some part of the world, and some were selling the same thing in kgs, some were selling in tons, like that. So it was ununiform. So what they sat and they decided to have one system of units, and that they considered. How they considered, what they considered, that will be seeing later. But that was system internationally. That was the International System of Units. Even that we follow now. SI unit. Agree? Fine. Ritika? Okay. Akhil? Good. Chitesh? Okay.
Yes, sir.
Good, 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 everyone. Now we'll be seeing what were the basic units that were used in system international unit. So first was one meter. How they defined meter? Okay, so meter they defined as the length traveled by light. 1 meter, basically they defined 1 meter. 1 meter was the length traveled by light in time interval of 1 by, what is the exact speed of light? Anybody? Speed of light? Who knows that? Anybody knowing speed of light? No one.
3 into 10 to the power 8 meter per second.
Very good. That is lump sum. Exact value is 299,792,458 meter per second. Right. So everybody know distance. What is velocity? Velocity is distance upon time, and we can calculate from here distance as velocity into time, right? So if we consider the velocity of light as 299,792 and 458, and we have to like find the distance traveled by light in this much time. So we'll multiply by this time, 1 by 299,792, 458. And when you multiply this, what will you get? You'll get 1. So this was what defined as 1 meter. Got it, everyone? This is how they took 1 meter. So what is 1 meter? 1 meter is the length traveled by light in the time interval of 1 by 299,792,458 meter per second. Okay. And what is this? This is the speed of light. Everyone understood? Second thing, what they defined? They defined time. How they define time? Second. How they define second? Second is, yeah, this was quite interesting. So 1 second is the duration of 1 second is the duration of 9,192,631,770 periods of radiation corresponding to I'll explain that. Transition between hyperfine levels of ground state of cesium-133 atom. So first, everybody tell me, who all know that atoms radiate? You know that? Atoms in the universe radiate. There are radiating atoms. You know this or not? Everyone? Okay. So atoms radiate. Okay, and they radiate and they reduce themselves in size. And cesium is one of the most radioactive elements. Okay, so what happens? They radiate some like some of their matters into the universe with a kind of radiation, and they get their size reduced. Okay, so what second was defined? Second was defined as this much. You don't have to remember this. They won't be asking you. This is just for your knowledge. This much period of radiation corresponding to the cesium atom. Okay, if cesium atom is like radiating this much of their amount, so that will take 1 second. Got it? Like, no need to put much into your mind into this. Okay, this is just a kind of definition for you. No numerical, no definition will be asked with it. I'm just explaining it for your information, like how they got this 1 second. Understood? Everyone, any doubt there? No, na? Okay, good. Next thing, kg, kilogram. How they define kilogram? So 1 kilogram 1 kilogram is mass of prototype cylinder mass of prototype cylinder of platinum iridium alloy. Height equal to diameter. Kept at Seviers near Paris. So what they did, they made one iridium platinum alloy whose height was equal to the diameter. Okay, and they weighed them. They got 1 kg. They defined that particular weight to be 1 kg. Okay. Now, why they took this particular element? Can anybody explain me? Any wild guesses? Why they took this element? And even this was not an element present in the nature. This was an alloy. What do you know about alloy? What is alloy? Vandana?
It is a mixture of
Very good. Mixture of 2 or more materials. So why they took this particular thing? If you have studied about alloy, you must be answering this. Akhil? Any guesses? No? Any wild guesses you can make? Chitesh?
So what was the question? Why they
Question
took
is like, why they took this particular alloy? Ritika? Nivedita? Anyone? Wild guesses? You're a science student. You should think anything. When my teacher used to ask, I used to answer anything. Yeah, go on.
Sir, maybe
Because alloys have best of their properties. Alloys don't change with time or temperature or pressure. Okay, so it was basically kept near Paris because Paris had a very good temperature, near about 27 degrees Celsius, 25, 27 degrees Celsius. It was not even quite warm or quite cold. Okay, so that's why they chose this place, because even when all of the weights of this world will be out of sight, we won't be able to find them. We will come to this place, we'll weigh it again, and we'll make them accordingly after that.
Sir,
Okay.
can you repeat the name of the place?
Seviers. I've written it here. Kept at Seviers. Severes. Near Paris. It is somewhere near Paris. So they have their international bureau there. That office is there. Okay. So this platinum alloy, platinum iridium alloy, is chosen because it does not get changed with or the alters with the temperature or the pressure or anything. So it is standard there. It is kept there and is kept uniform there. Got it? As we had now for characteristics of physical units, that it should be unchangeable. Got it? Understood, everyone? Mole you can define. Mole easy. 1 mole is nothing but the number of elementary particles in 0.012 kg of C12 atom, carbon 12. Remember, class 9 mole. Earlier, what atoms were chosen for defining mole? Anyone? What atoms are chosen? Oxygen was there. Who answered? Who answered that?
Sir, Nivedita.
Okay, good. One more. One more atom was chosen. Hydrogen was also considered. You know what was the basic thing behind that consideration? They wanted to get the exact number because they wanted to like measure other quantities. Okay, the thing was that, see, earlier hydrogen was chosen. Hydrogen was considered the atomic mass 1. So what they did, they considered that 8 hydrogen atoms are required to balance the weight of 1 oxygen atom. So then they said that oxygen is 8 times U, unified unit. And 1 unit was what? The weight of 1 hydrogen atom. But later on, they discovered that it is not exactly 1. It is 1.000008. I'll say, sir, how will they differ? This is so small. You know how many atoms are there in 1 mole? Of the order 10 to the power 23, na? And this is of the order of what? 1, 2, 3, 4, 5, 6, 7. So this will create a difference in 10 to the power 16 order. And that is really huge. Agree? You should remember everything. Everything that you have been taught is of some use, and you should remember that. Okay, next thing. We have to define ampere. Ampere is the unit of what? Ampere is the unit of
Current.
current. Good. Ampere is the unit of current. So it was defined as it is that constant current if placed in two straight, or I should write maintained in two straight parallel conductors of infinite length and negligible cross-section area. And placed 1 meter apart, would produce a force of 2 into 10 to the power minus 7 Newton. So you all don't know basically what happens if two like current carrying conductors are kept at certain distance to each other parallelly. So they attract or repel each other based on the current direction. That you'll be studying in class 12. Magnetism. I think you must have studied in class 10th also. Magnetism. Two parallel conducting wires attract or repel each other. If they're in the same direction, they attract each other. If they're in the opposite direction, they repel each other. I guess you have read something like this. So this was described from there. Okay. So just write it down. Written, everyone. Shall we move on to the next page? Okay. I'm waiting. No problem. But write fast because you have to do lots of things. Done? So you don't have these things as note, now. Okay. Written, shall we move on? Everyone? Nivedita, written?
Yes, sir.
Akhil, written? Good. Pratika, written?
Yes, sir.
Okay. Ritesh also? Done? Okay, Vandana is already done. Okay, let us move on. Last point that we have to do is Kelvin. Kelvin. What is Kelvin? One Kelvin is fraction of 1 upon 273.16 of the hydrodynamic temperature of triple point of water. So what is this? What is triple point of water? Anybody can answer what is triple point of water? What are the 3 phases of water? Tell me fast. 3 phases of water. Anybody? So 3 phases of water are solid, liquid, and gas, right? You must have known that we can get 2-phased water system at 0 degrees Celsius, right? If we keep the water at 0 degrees Celsius, what happens? We can see partially solid phase and partially liquid phase. Agree, everyone? You must have seen that in your fridge. Like when the temperature is nearly about 0 degree, you can see that partially of the liquid in the ice boxes has converted into ice and a part of them is as liquid. There is a point of temperature at which we can get all the 3 phases, be it solid, be it liquid, be it gas. The gaseous form is water vapor. Okay, so that temperature is 273.16. That is called triple point of water. We'll be studying it later. You must have seen that chapter thermodynamics in your syllabus if you have turned the index of your physics book. I don't know whether you go through that or not, but when I used to get any book, I used to read whole book, irrespective of what I know, what I don't know. Do you have interest in physics? Do you feel physics interesting? Whatever you have to study, you have studied in class 9. Whatever you have studied in class 9, same thing you'll be studying in class 11. Whatever you have studied in class 10, same thing you'll be studying in class 12. The same thing gets copied, just the syllabus expands. That thing is there. Understood? So if you're targeting some exam like JEE or NEET, so you should be targeting physics basically. You have to dive into physics. You have to love physics. Okay. So get anything of it. If you don't like it, you have to remove that from your mind if you want to target anything. So that particular point is triple point of water, and at that point of time, what happens? If you divide by same thing, you get 1 Kelvin, isn't it? If you take 1 by 273.16 and you multiply the same thing, you'll get 1 now, isn't it? Okay, so that's how they got 1 Kelvin. You don't have to remember all these things. These are not important, but they may ask you in school exam. So we have to target that also. Okay, so that's why I'm making you write all these things. As you said that you don't have these notes. So beyond these fundamental and derived quantities, there are 2 more quantities. Okay, that is called supplementary quantities. Okay, supplementary quantities. Supplementary quantities. What are supplementary quantities? Basically, they don't have units. They are unitless. If you go through the values, for example, if I ask you what is velocity, so velocity writes a distance upon time. And what is the unit? So you say, sir, distance has the unit meter and time has the unit of seconds. So the velocity should have the unit of meter per second. That's how you go, right? But in this case, if I write, one is radian, another one is steradian. Steradian. So what is radian and steradian? See, have you like ever been to Domino's or Pizza Hut and you ate pizza there? You only get a pie there, na? Because all others are eaten by your friends, isn't it? So you get a pie there that has some 2D angle. If I visualize this in 2D, it will be having some 2D angle in a planar geometry. I can represent that in a plane. That's why I'm saying it is to planar geometry. Agree? Angles are represented as theta. I'm using the word theta. Any problem there? Okay, good. So what happens? This is having some kind of arc length. This is the arc ds. I'm writing arc length, and this is the radius of that particular pie, right? So radian represents this 2D geometrical angle, that is theta, and that is the value is given by ds upon r. ds upon r. So if you see what is ds, what is the unit of ds? What is the unit of ds? What
Meters,
should be the unit of ds? Huh?
meters, because it's length of the,
Exactly, exactly. Very good. It is a length, so it should be meters. And what should be the unit of r? R, what should be the unit of r? Same, meters, because that is also a length. Now, if you divide it with the units, so this is meter, this should be meter, then theta should has no units. But when I ask you, you have studied this in trigonometry basically. What is the unit of theta? Angle. What is the system of international SI unit of angle?
Radians.
Chitesh?
Degrees.
Degree is not the SI unit. Degree is
Radian.
one of the units, not SI unit.
radians.
Radian is the unit. Exactly. Radian is the unit. So that's why these are called supplementary quantities, because they do not have that their own unit, but still they have got their names. Okay. Now what is steradian? So tell me who all have went to buy watermelon. Watermelon. Okay. How do you buy watermelon? Just a funny question. You ask that man to give me a cut piece of it. I'll check it whether this is red or not, and then you buy it. Agree? Yeah, you must have seen this. If you have not done this, your parents, you must have seen your parents doing this. So what he does, he cuts something like this. He cuts something like this, and he takes it out, and it gets to be something like a pyramidal shape, right? I shall make it in dotted form. Yeah. Just a minute. It seems something like this. Agree? So there will be some angle here, na solid angle, that we cannot represent in the 2D figure. I'm just trying to make it. Some solid angle will be there. Agree or not? That solid angle, this, let us say this is the base area. This is the base area. Whatever base he has cut, this is the area. Okay, and this is the radius. So this solid angle is represented as this ohm sign. Is what? This area, dA, let us say this is dA and upon r square. Now tell me, sir, what is the unit of dA? What is the unit of dA? If it is area?
Meter square.
Meter square. And what should be the unit of r square?
Meter square.
Meter square. So with that rule, it should be unitless, na? There are quantities which are unitless. You have learnt about refractive index in your class 10th. That is unitless. Agree or not? So you have to relate physics. Then only you'll be able to understand it. You'll be fix it, and then you'll be get this in your mind. You won't have to remember it anything. I'll try not to make you remember anything. But still, they has got unit. They have got units, that is steradian. That's why they are called supplementary quantities, and they are kept away from fundamental and derived quantities. Agree or not? Everybody?
Yes, sir.
Good. till now we have not come to any of the numericals. I'll try to make more of the numericals there. That is most important. But these are the basics, and we have to do this because they are something like this in the exam, school exams. So if you're not able to write there, you'll get demotivated if you don't get marks, because you must have scored class 10th in a very better manner, more than 90%, 95%. That's quite easy to score, isn't it? And the same expectation you do, but 11th and 10th is quite different. You have to work hard. 10th, you can score 95% by just studying 2 or 3 hours a day. For 11th and 12th, and for targeting some examinations, you must have seen the results. What are you targeting all? NEET or JEE?
JEE.
JEE. Everybody? JEE only. So you have to be best of it. You have to practice every question from all the books. 3, 4, 5 books you have to make. And still you'll be finding it difficult to solve the questions of the sample papers. Because the questions are different, the levels are different. You have to work a lot. Okay, we don't have to feel demotivated. We have to work a lot, and then we'll get everything, right? Okay, then that's all for today for physics. We'll be just joining in 5 minutes. That is, it is 6:33 right now. We'll be joining at 6:40 exactly, and then we'll continue for 1 hour for maths, right?
Yes, sir.
Liking the session? Liking the session?
Same link, sir.
Yeah. Go on, Chitesh. Any doubt?
No, sir. I just stay in the meeting.
Okay.
I have really.
So I hope you're liking the session. Any change in you want me to change in my teaching methodology? Anybody? Nivedita, Ratika, Akhil, where is he?
Sir.
Okay, then good. You can take rest for 5 minutes and then rejoin. Bye.
Thank you.